Let's see, I've got a minute and a half after, so I'm going to go ahead and start. If anybody else comes, I'll let them join in. This is our 11th day of the review, and we're going to go over sequences and series. It was one of the last things we all did together when we were back in class. You have to check and see if a sequence is either arithmetic or geometric. You have to find a term in that sequence, like the 12th term, the 23rd term. You have to find the missing term, that's called the means, the arithmetic or geometric mean. You have to evaluate or find the sum of a series, that's what evaluate means. Summation notation is a big Greek letter E, and it's also the same as evaluate, it means find the sum of that series. You want to check if a series diverges or converges. And your two things that you have to turn in work for are your and your exit ticket. And your Desmos activity, I'll do Desmos in a minute. Let's see who we got here. It's so hard to get. Okay, doing too. Wow. Once again, a full crowd. Good morning, Kaylin. Good morning, Sanaya. Hope you ladies are doing good today. Okay, and then they sent letters home for all of your homes yesterday, and expect it today in the mail or probably tomorrow at the latest, and it explains what they're going to do for last period, period grading. And so I need all of your work by the 29th because my grades are due, I think, on June 2nd, and I can't wait until the very last moment to submit because too many people will throw everything at me all at once and I won't get it all in on time. So, I mean, everything that I have open still, and that's days 5 through 11 today, has to be turned in by the 29th of May for your final marking period grade. You do not get till June to do all this. I did close days 1 through 4, and I'm only accepting all the way through this week's at this point. Too many people are waiting to the last minute to turn it in and then hoping they get to resubmit. I'm not taking resubmit. So once you've turned it in and I've graded it, you're stuck. You can't keep going back and trying to fix it for me because I feel like I'm giving all the instructions in the videos. And if people don't want to watch the videos, that shouldn't make more work on me. Okay. So this was part of something that went home for teachers, but I'm hoping somewhere in your literature you're getting this as well. So what they're going to do is, if you've got a passing grade by May 29th in your SOL courses, that's my Algebra 2 and any other classes that you would have taken in SOL in this year, then you get the SOL credit. So all you need is a 64 and higher to get that credit. They're actually rounding it 63.5 and higher. So if by the 29th of May you've turned in enough work that you have a passing grade, you will get the locally awarded verified credit, which is like the SOL, only different. And you're done. You won't have to do anything else. If you don't have a passing grade, they're going to have a test window for any underclassmen or middle schoolers who are in Algebra 1 or Geometry to take this Mastery Connect test that they're going to open up on May 25th. That's Sunday, I believe. No, that's Monday. That is actually Memorial Day. So they're going to open this up because I hear a lot of feedback coming from somebody. They're going to open this test up next Monday, Memorial Day, for anybody who's not passing the course yet, and you get an opportunity to take this test and see if you pass it to get your locally awarded verified credit. And then if you miss that or if you fail that test, then you have the opportunity in the fall, during the first 6 weeks of school, to complete phase 2 of the alternative learning plan. So they're going to make you go back in the fall and turn this stuff in and then say you'll get the locally awarded verified credit. Okay. So if you miss the test or you haven't turned in enough work to get it, you're going to have a chance again in the fall to do it. So I want you guys to actually stop and think about what that means. That means by next Friday, all of this has to be done. It has to be wrapped up for us. And there's something that they were talking about. You can still continue to submit after the grades go out, but you won't be able to change your report card grade. So the 29th is the last day I'm taking work. And then if you submit after that, it's not going to increase your grade. So if you're like on the verge of getting a D, you won't be able to submit anymore to up your grade, but you can still submit. For some strange reason, they want you to continue to submit. So I'm not sure what they're doing there. Anyways, please take time to actually go through this. I don't want there to be any surprises. I'll try and send an email out to parents so that everybody understands, but a lot of my emails bounce back. All right, so let's get straight to the work. Sequences in series. So a sub n represents the nth term. Like if I want the 12th term, I would say a sub 12, and 12 would be my n value. S sub n represents the sum of the first 12 terms. So a sub n is just that one term. S sub n is the sum of all of them. Of course, S sub infinity represents the sum of an infinite geometric series. There's no such thing as S sub infinity for an arithmetic series. R is your common ratio, and that's what you get when you divide the terms backwards, consecutive terms divided backwards. And D is your common difference, and that's what you get when you subtract consecutive terms backwards. So you take the a sub 2 term and subtract the a sub 1, not the other way around. These are your formulas for arithmetic, and remember I said this second formula is the recursive formula. Let me actually write that in here. This is recursive, C-U-R-E. And we rarely use it, but they do think it's important, so they leave it in the formula sheet. And basically what it says is you can find any term in a sequence if you know the term before it. So if I'm looking for the 13th term, as long as I know the 12th term, I can just add the common difference. Or if I'm looking for the 13th term here, I can take the 12th term and multiply by the common ratio. And then this is the sum for an arithmetic sequence if you know the first and last term. If you don't know the last term, you can use this S sub n formula. This one works for everything. All you need is the first term in this one. Here you need both first and last. And this is the S sub n for any geometric sequence, as long as you know the first term, the common ratio, and how many terms you're going to. And if you have an infinite number of terms, you just use the first term and the common ratio, so long as your common ratio is less than the number 1. The absolute value is less than the number 1. All right, so the first problem I'm going to give you is a recursive problem. So let's say I tell you A1 is 100, and let's say I want you to use this formula. A sub n is 1/2 n minus a sub n minus 1 plus 2, and I'm looking for the 5th term. Okay, so it doesn't matter if it's arithmetic or geometric. I have my formula, and I just take this term, the first term, and I stick it in here to get the next term. So if I stuck a 100 in here, I would be saying a sub 2 is 1/2 of a sub 1 plus 2, or 1/2 of 100 plus 2, which is 52. Okay, now that I know 52 is a sub 2, I can stick that in here to get a sub 3. So you can see it's just a cycle that repeats. Once you know the last term, you can get the next term. So I'm doing 1/2 of 52 plus 2 is 28. And then I can take the 28 and go back and put that up in here. And of course, that's 1/2 of 28 plus 2 is 16. And then one last time. That's how you use a recursive formula. You just plug in one at a time until you get to the number you're looking for. And we were looking for the 5th term. Okay, so if it says find the nth term, the 12th, 13th, 14th term, you're going to use your a sub n formula, but you have to first check, is it arithmetic or geometric? So if I subtract backwards, negative 18 minus negative 11, never subtract forward. It's very important you subtract backwards or the signs are wrong. Then I get negative 7. If I subtract negative 25 minus negative 18, I also get negative 7, and negative 32 minus negative 25, I also get negative 7. So since I subtracted backwards, that's a difference, and that makes this arithmetic. So I'm using this a sub n formula for arithmetic. So I need a1, that's negative 11. I need n, we're going to 12 terms, so n is 12, and I need my common difference, and that's negative 7. And so I put in that, and I got negative 88. Okay, now for this one, I'm going to try dividing backwards to see if I get the same thing. So I divided negative 2/6 by positive 1/2, and I divided 4/18 by negative 2/6, and so on. And I got the same number all 3 times. I got negative 2/3. So that makes it geometric. So your a sub n formula is a1 times r to the n minus 1. a1 is 1/2. R is what we just figured out, negative 2/3. And n, of course, is 12. So I got this number, okay? And usually if it's a fraction formula, you want a fraction answer, but I think I tried to convert this and it wouldn't convert, so I had to leave it as a decimal. Okay, find the sum of the series. That's when you evaluate something. Now I'm looking for all the terms up to ninth term. So this goes -1, +3, -9, and so on. And I could just generate all 9 terms and add them, but I know that there's a formula. And I know it's going to be geometric because 3 divided by -1 is the same as -9 divided by 3. Both of those are -3. So A1 is -1, R is -3, N is 9, and I have everything I need. Okay, I did not uncover the infinity formula because I'm not going to infinity, so I'm not going to use that one. So for this one, I wonder if it's arithmetic or geometric. It looks like each of the terms goes up by a little each time, so I'm going to assume that -9 minus 13, -5 minus -9, -1 minus 5. Let's check what those are. Those are all 4. So if my common difference is 4, I'm going to use, and I don't know what my last term is. So I can't use this formula because it just says 3 ... to 21, and I'm not about to find all 21 terms. So I'm going to skip this formula and I'm going to use the one below it. I'm going to say, let's use this one where all I needed is the first term, the number of terms, and the common difference. So the number of terms is 21. The first term is -13. Again, the number of terms is 21 and the common difference is 4. So if you put all of that in your calculator at once, you get 567. Please remember when you're doing your work to actually show me all of the formula. Don't just say D is 4, S21 is 567. It was all on my calculator. Actually show me all of what you did so that if I had to grab a calculator and go back behind you, I wouldn't have to go back and look for the formula. It would all be right there. Okay, now we get to the arithmetic and geometric means. So if you're looking for the arithmetic mean, you add the two numbers and divide in half. So I added 4 plus 16 and divided in half, and I got 10. If I'm looking for the geometric mean, I multiply the two numbers and take their square root. So the square root of 4 times 16 is 8. So if you have more than one blank, you go to the middle first. So if I'm looking for the arithmetic mean between these two numbers, I go to this middle one and do -122 plus 46 divided in half, and I got -38. And then I use the -122 and the -38 and do this one, and I use the -38 and the 46 and do this one. So remember, you're doing the same formula. You're doing the first plus the last divided in half to get the middle term. So for geometric, I'm multiplying 2 times 13,122, and I'm taking that square root. So that gave me 162. Then 2 times 162 square root is 18, and then 162 times 13,122 square root is 1,458. Also notice that this is not on your formula sheet. So if you're looking for missing terms, you have to know these formulas. You have to know a plus b over 2 or square root of a times b. It won't be on your formula sheet. Okay, and then when we're looking for whether it diverges or converges, if it converges, there is a sum. So if it converges, you use the infinity formula. If it diverges, the absolute value of r is going to be greater than or equal to 1, and you can't use any formula because there won't be a sum. So the first thing is to check r. So if I divide 0.5 over 0.1, that gives me 5, and the absolute value of 5 is greater than 1. So this one diverges. It has to be less than 1 to converge. So I cannot find the sum here. Now, if I divide 1/2 by -1, I get -1/2, and the absolute value of -1/2 is +1/2, which is less than 1. So this series converges, so I can use this formula. So a sub 1 is -1, and r is -1/2. You have to go back to the original r, not the absolute valued one. So I'm going to put in -1 for a1, 1 minus, don't drop this minus sign just because r was already negative, 1 minus -1/2, and that gives me -2/3 for the sum of that series. So that's how you check if it converges or diverges. You just need to know its r value. And for the r's that are less than 1, the absolute values are less than 1, you can use the infinity formula. Okay. You have 3 warm-up problems and 2 exit ticket problems. So here's what I need to see for work. When they're asking you which is geometric, show me how you divided backwards and got the same r every time before you circle A, B, C, or D. Do not just point to one and say r equals. Show me you divided backwards. For number 2, I need you to plug in twice. This is like the recursive formula. Start with A1 is 7 and plug it in here. And then whatever you get for that, use that number to plug in again. So you're going to say 4 minus 10 times 7 equals, let's say it equals x. Then you're going to say 4 minus 10 times x. Let's say that equals y. Then 4 minus 10 times y. That would be your answer for the third term. All right, what is the value of this? This is summation notation. So what this means is you have to plug in the bottom number, and I think that bottom number is a 3. It's kind of hard to see until you get to the top number, going up by 1 each time. And then all of those answers have to be added together. So I would say 5 times 3 plus 1, if I plug in the 3, then 5 times 4 plus 1, then 5 times 5 plus 1, and then 5 times 6 plus 1. And then I would add all of those together. I need to see that work. Do not tell me you put it in Desmos. And don't say it's in my calculator, because I have absolutely zero way of verifying it really is in your calculator. It could have been in your friend's calculator. They told you the answer and you told me it was in yours. So show me this work on your page. It won't take you that long, and I'm asking you to plug in. For this one, it has the infinity formula up above, but I'm telling you, you can use this formula if you know A1 and R. And I'm pointing to R right here. R is in the parentheses, it's 1/2. So all you need is A1. So take this bottom number, plug it into this formula, and that will give you A1. And then you'll have the A1 and the R, and you can do the formula for infinity. Again, do not tell me it's in Desmos. And then for this one, just plug in the number 12. If they're looking for the 12th term, it says find a sub 12, then you're going to plug 12 in for this n and this n. And don't forget to use pretty print so that you don't divide this by 2n squared and then subtract 3 off to the side. So it's not going to be hard. It's going to be easy. And then you have a Desmos activity called AV and Benita's Repair Shop. I think that's sequences in series. Please don't send me your Desmos work. Just send me the warm-up and exit ticket work, and you must show real work, not reference me to some calculator somewhere, okay? So that's all I have. And everything for this week, that's days 11 and 12. I guess I'll see you guys again on Thursday. Will be due Sunday night. But everything that's still open will be due next Friday, the 29th. Do you guys have any questions at all? I'm going to unmute everybody now. Faith, do you have anything? Sanaya, how about you? Are you good? Okay. Kaylin, are you?
I'm good.
Okay. All right, guys. Thank you for showing up. I'm going to take off, and if you have any questions, you can continue to email. Okay?